Refraction of light by spherical lenses. So first we'll see what is a lens. A lens is a piece of transparent glass bounded by two spherical surfaces. In this lesson, we will deal with two kinds of lenses. The first lens, which we'll call the convex lens, and here we have the concave lens. Now, why is it called the convex lens? Because in this you can see these two surfaces are convex surfaces. There are two bulging surfaces, hence the name biconvex lens. You can also notice that the lens is thick in the center and thinner at the edges. So the convex lens is thick at the center but thinner at the edges. There are more differences which we will learn later. Then we have the concave lens. Now, why is it called a concave lens? Because it is made up of two surfaces that are concave. Have you seen like a cave? They are bulging inwards. So this is in fact called a biconcave lens. It is bulging inwards. And if you see, it is thin in the center and thicker at the edges. Concave lens is thin at the center but thicker at the edges. So in this lesson we will deal with two lenses, convex and the concave. There are many more differences that we will also study a little later. So to recap this slide, we have two lenses, one is a convex and one is a concave lens. And lenses, if you see, are bound by two spherical surfaces. Like in this case, have you seen this surface is spherical, it's not plain surface, it's a spherical surface. The concave also is bound by two spherical surfaces. We'll now learn about the principal focus and the focal length of the lens. First, we must know what is the optical center of the lens. The center of the lens, let's put it a little bigger, this center of the lens is called the optical center, and it is usually denoted as C or O. So optical center is the center of the lens. Is known as its optical center. Now that we know the optical center, let us see what you mean by principal axis of a lens. It's a line that passes through this optical center and is perpendicular to the surface of the lens. So the principal axis of a lens is a line passing through the optical center in this case it is C of the lens and perpendicular to both the faces. Of the lens. So this is the principal axis. So just repeat again, the principal axis is a line passing through optical center of the lens and perpendicular to both the faces of the lens. This is called the principal axis. Next we will learn what is the focus of the lens. Now rays that are parallel to the principal axis, all these rays which are parallel to the principal axis, after refraction they all meet at a point on the principal axis. They undergo refraction through the lens and they meet at this point here. This point where they meet is called the focus of the lens. So this is the focus. So let us now go ahead and define the focus of the lens. So rays that are parallel to the principal axis after refraction through the lens meet at a point on the principal axis. Called the focus. So this point is the focus. Is the focus of the lens. So once again, rays that are parallel to the principal axis after refraction through the lens meet at a point on the principal axis. This is the focus of the lens. Now for the focal length, it will be the distance between the optical center. Here is the optical center. This distance between the optical center and the focus, this distance is called the focal length. So to define focal length is distance between optical center of the lens and focus of the lens. So between optical center and focus is called the focal length of the lens. Here's another picture of the convex lens, and to explain it again, rays that are parallel, see these rays are parallel, and these rays parallel to the principal axis. After refraction, they all meet at a point here. This point is called the principal. It's called the principal focus or the focal point. And the distance between the optical center and this focal point is called the focal length. The optical center is somewhere in the middle here, the center of the lens. Now if you notice here, this is a convex lens, and this convex lens is a converging lens. It converges all the rays of light. It brings all the rays of light together. So it is also called a converging lens. Now we'll learn about the concave lens. So here we have the concave lens, which will also have its principal, will have its optical center, the center of the lens. So this is the optical center. We mark it at C. So C is optical center. And just like the convex lens, optical center is the center of the lens. Then we have the principal focus. Just like the convex, the principal focus is a line passing through the optical center and perpendicular to the surfaces of the lens. So we have principal axis. And how do we define principal axis? It has got 2 points, a line that passes through the center or through the optical center, 1 point, and the second point perpendicular to the surface, perpendicular to the surfaces of the lens. So that is the principal axis. Now again here too we will define the focus. To define the focus, you always take rays that are parallel to the principal axis. So these are rays that are parallel to the principal axis. Now this concave lens behaves in a different manner. The rays that are parallel, after refraction, they diverge. But they all appear to come from one particular point. If we produce this backwards, they all appear to come from one point. And this point is said to be, here this point is the focus of the lens. So here we put it F. So we have the focus of the lens here. So we define the focus of the lens as rays parallel to the principal axis after a refraction diverge. See, they move away from one another but appear to diverge from a point on the principal axis. And this point is called the focus of the lens. Now to find the focal length. The focal length, again, definition is the same. It is a distance between the focus and the optical center. So this distance. So if I want to define focal length, distance between optical center and focus of lens. So this distance between the optical center and the focus is called the focal length of the lens. So here's a picture of the concave lens again. The center here of the lens is called the optical center. Then we see that the rays that are parallel to the principal axis, these are rays parallel to the principal axis. After refraction, they all diverge, but on diverging they all appear to come from a point here on the principal axis, and that is the focus. Here is the focus, and the focal length, distance between the focus and the optical center. And if you notice, this is a concave lens because the surfaces are concave, and a concave lens is a diverging lens. It diverges the rays, it spreads out the rays, unlike the convex which converges the rays. So we make a little comparison between the concave and the convex lens. So the first lens here is convex, and we have seen that the convex lens is a converging lens. The rays meet, it brings rays together, converging lens. And here we have a concave lens, and in the concave lens the rays spread out. It's a diverging lens. Now when it comes to the focus, if you notice here, the focus, the rays actually meet at the focus. So focus is real. You will be able to capture it on a screen. That spot will be bright. If you keep a paper at this spot here, you will get nice and bright. But here you see the ray at the focus, the rays do not actually meet, they appear to meet. So in concave, the focus is virtual. If you keep a screen there, you will not get a bright spot, cannot be captured on the screen. And of course, the other difference, the structure. Here at the center, it is thick. At the edges, it is thin. But when we come to concave, at the center, it is thin, and at the edges, it is thick. There are many more differences between concave and convex, but this is what you learned till now.